Assalamualaikum and hi, my name is Aliah HUSNA. So today I want to present to you about what is differentiation. Differentiation is a method of finding the derivative of a function. In this video, we are going to cover the topic of applications of differentiation. There are 5 subtopics, which is related rates, analysis of polynomial function, analysis of rational function, applied maximum and minimum, Rolle's theorem, and mean value.
My name is AISYA binti AFIZI. What is analysis of function? Analysis of function is to determine the relative maximum and minimum points and inflection point, if any, to sketch a rough graph of an equation. Then, for apply maximum and minimum problems is to identify the maximum or minimum value of a certain problem. Now, let's go to our first question. First question is to cover analysis of polynomial function. Here is the question. Determine the relative extreme points for the following function. Fx equal to 2x cubed minus 3x squared minus 36x plus 14. Okay, first we are going to use the first derivative to identify the extreme points. Now, we are going to differentiate the equation. Then, we are going to find the value of x, which is 3 and negative 2. These two values are the critical values. By using the critical values, determine the interval and then use the intervals to identify the increasing and decreasing functions using the first derivative table. If the function has a positive value, the graph will be increasing and vice versa. After that, substitute each critical value into the original equation to determine the extreme points. This is the maximum point, and this is the minimum point. Now, let's go to the second step. Here, we are going to use the second derivative to identify the inflection point. Based on the first derivative, we are going to differentiate the equation again. Then find the value of x. This value will be the intervals used in the second derivative table. If the function has a positive value, the graph will be concave up, and if the function has a negative value, it will be concave down. For the last step, substitute x value into the original equation to obtain the inflection point. Now, using all the data we have acquired, we can sketch a rough graph such as shown on the screen.
Now, for our second question. This question is to cover analysis of rational function. Here is the question. Given the function is fx equal to 3x divided by x minus 4, find the x-intercept and y-intercept, the vertical asymptote and horizontal asymptote including the analysis, the intervals where fx is increasing or decreasing, hence determine the extreme point, the intervals where fx is concave up or down, hence determine the inflection point, and lastly, sketch the graph of fx by using the information above. Okay, first we are going to find the x-intercept while y equal to 0 and then substitute f with the value of 0 to get the y-intercept. That's how you get the answer for question A. Now, we are going to identify the asymptotes for question B. For the horizontal asymptote, find the limit of fx when x approaches plus minus infinity. To do that, we are going to divide the numerator and denominator with the highest degree of x in denominator. Then, we are going to get y equals to 3. For the vertical asymptote, let the denominator of a rational function equal to 0. Then, find its analysis by approaching the values from the left and right hand sides. In this question, x approaching 4 negative is 3.9 and you will get negative infinity. While x approaching 4 positive is 4.1, you will get positive infinity. For question C, we are going to identify where fx is increasing and decreasing and extreme points. To do this, we are going to use the first derivative to test. differentiate 3x divided by x minus 4, we will get negative 12 divided by x minus 4 square. Here, we can identify that there is no critical value, so relative extremum points do not exist. Using the first derivative table with equation just now, we can identify where fx is increasing and decreasing. As you can see, fx is decreasing at negative infinity for union for infinity. Moving on to question D, we are going to use the second derivative test to identify the concavity of the equation. Differentiate negative 12 divided by x minus 4 square, and then we will get 24 over x minus 4 cube. Here, there is no inflection point. Then, using the second derivative table with the new equation, we can identify the concavity interval. Negative infinity 4 has a negative value, so it is concave down, while interval 4 positive infinity has a positive value, so it is concave up. Lastly, for question E, we are going to sketch the graph using all of the information we have acquired, as you can see on the screen.
Hi, my name is AUFA binti ABDULLAH. Now for the last question, we are going to cover the subtopic applied maximum and minimum problems. Let's see the question. All four equal size squares with sides x centimeter are cut out from each corner of a thin rectangular metal with dimension 15 centimeters times x 8 centimeters. The metal is folded up at the perforated line to perform an open box. Show that the volume of the box is given as volume equals to 120x minus 46x power of 2 plus 4x power of 3. Find the value of x to maximize the volume. How to solve this question? First, we are going to use the first derivative test to find the values of the variables. After differentiating the equation, we are going to get the 120 minus 92x plus 12x power of 2 equals to 0. Then, after factoring the equation, we are going to find the values of x by using the formula x equals to negative b plus minus square root b power of 2 minus 4ac over 2a. As you can see, we will get 6 and 5 over 3 for the values of x. After that, we will use the second derivative test to identify whether fx is a maximum or minimum value. First, we are going to differentiate the first derivative again to get the second derivative, which is negative 92 plus 24x. Then, substitute the values of x that we have acquired just now into the second derivative to obtain the maximum or minimum value. If the value is more than 0, it is a maximum value, hence the graph will concave up and the value is minimized. If the value is less than 0, it is a minimum value, hence the graph will concave down and the value is maximized. The question asks for the value of x to maximize the volume. Hence, the answer is x equal to 5 over 3 centimeters. Now that is all for our video. As a conclusion, by applying differentiation method into these problems, we can conclude that the application of differentiation can be used to analyze polynomial functions, analyze rational functions, and lastly, apply maximum and minimum problems.